Committee on Science, Space, and Technology will come to order. Welcome to today's hearing entitled Mars Flyby 2021, the first deep space mission for the Orion and Space Launch System. I'll recognize myself for an opening statement and then the ranking member for an opening statement. At a fundamental level, space exploration, the mission of NASA, is about inspiration. This inspiration fuels our desire to push the boundaries of the possible and reach beyond our own pale blue dot. For years, I have heard countless stories of how NASA inspired students to study math, chemistry, and physics, and adults to become scientists and engineers. However, some of these same people now feel that NASA no longer inspires them, their children, or grandchildren. Mankind's first steps to the moon are a distant memory. And with the retirement of the space shuttle, NASA now is paying Russia $70 million per seat to transport American astronauts to the International Space Station. There's a sense that America is falling behind with our best days behind us. Today, America's finest spaceships and largest rockets are found in museums rather than on launch pads. Regrettably, the Obama administration has contributed to this situation. Within a few months of taking office, the President canceled NASA's plans to return astronauts to the moon. And in its place, the President proposed a robotic and human mission to an unnamed asteroid. NASA's own advisory group on asteroids derided this plan and said, quote, "It was not considered to be a serious proposal," end quote. At a hearing before this committee, all of the witnesses questioned the merits of the proposed mission. While consensus on Capitol Hill might be hard to find, there is general agreement that the President's asteroid retrieval mission inspires neither the scientific community nor the public who would fit the bill. So what is an inspiring mission? Maybe a journey to Mars. The red planet has long intrigued mankind, and a Mars flyby with 2 astronauts on board NASA's Orion crew vehicle could use the space launch system that NASA is developing. This flyby would take advantage of a unique alignment between Earth and Mars in 2021 that would include a flyby of the planet Venus. This alignment minimizes the time and energy necessary for a flyby. Under the 2021 proposal, a trip to Mars would take roughly a year and a half instead of 2 to 3 years. We are not the only nation interested in extending humanity's reach into the solar system. One of the 3 major spacefaring nations will reach Mars first. The question is whether it will be the United States or China or Russia. Great nations do great things. President Kennedy's call to the nation wasn't just about reaching the moon. It was a reminder that we are an exceptional nation. We must rekindle within NASA the fire that blazed that trail to the moon. The future of this nation's exploration efforts lead to Mars. The first flag to fly on another planet in our solar system should be that of the United States. NASA, the White House, and Congress should consider this Mars flyby mission proposal. It will focus NASA's energy and talent over the next decade, and most importantly, it will inspire our nation. I'm going to yield the remainder of my time to the chairman of the Space Subcommittee, the gentleman from Mississippi, Mr. Palazzo.
Thank you, Mr. Chairman, and thank you for holding this hearing today. The future of human space exploration is one that is personal to me. As other spacefaring nations expand their programs and look to destinations such as the Moon and Mars, I consider American leadership in space as a matter of national pride, but also national security. This committee has been consistent in its commitment to human exploration. Yet over the last decade, the human exploration program at NASA has been plagued with instability from constantly changing requirements, budgets, and missions. We cannot change our program of record every time there is a new president. My subcommittee and this full committee passed a NASA Authorization Act last year that calls on NASA to develop a stepping stone plan to Mars. We must ensure that future exploration endeavors lay the groundwork for an eventual human landing on Mars. This committee must also maintain strong support for the next generation deep space vehicles, the Space Launch System and Orion crew capsule. I visited Marshall Space Flight Center, which is leading development of the SLS rocket, and I've had the opportunity to see SLS engine tests firsthand at Stennis Space Center in my own backyard in South Mississippi. I believe we're on the right track, but we must remain budget-focused and mission vigilant. I look forward to hearing what our witnesses have to say today. Thank you, Mr. Chairman, and I yield back.
Thank you, Mr. Palazzo. And if there is no objection, I'd like to put in the record a letter from Explore Mars expressing their support for a short-term flyby mission to Mars to be, as I say, put in the record. And if there's no objections, so ordered. And now I'll recognize the gentlewoman from Texas, the ranking member of the full committee, Ms. Johnson, for her opening statement.
Good morning. I want to join the chairman in welcoming our witnesses in today's hearing. I look forward to your testimony. I see that the hearing title asks the question, Mars Flyby 2021. The first deep space mission for the Orion and Space Launch System. The question, given that 2021 is currently the estimated date for the very first crewed mission of Orion, period, not just its first deep space mission, I would guess that the likely answer will turn out to be no. I doubt that a flyby of Mars will ultimately be considered to be an appropriate first shakedown of flight for new crewed spacecraft, given the risk involved in a year-and-a-half trip to Mars and back. However, I think this hearing does provide a good opportunity to again stress that we need a clear, thoughtful roadmap for our nation's human exploration program. Successive NASA authorizations acts have made clear that Congress believes that Mars is an appropriate goal for our nation's human spaceflight activities. It's time for NASA to tell us how they intend to achieve that goal, what technologies will be needed, what sequence of intermediate destinations should be pursued, and why, and what are the risks that will need to be addressed. We also need to hear from NASA about the progress being made on the Space Launch System and the Orion, the two systems that are critical to our exploration efforts beyond low Earth orbit. What are the challenges they're facing? How will they be used to support NASA's roadmap to Mars? And are they being adequately funded to meet the milestones laid out for those two programs? Mr. Chairman, NASA has not been invited to participate in today's hearing. That is unfortunate. I would urge you to schedule a follow-up hearing with NASA so that we can get a status report on the Space Launch System in Orion, as well as hear that what NASA is doing to develop a strategic roadmap for human Mars exploration. We need to hear from NASA if we are to properly assess its human exploration program and the funding that will be proposed for it when the President submits his budget request to Congress next week. It will also be relevant for this committee as we move forward on our reauthorization of NASA. Our nation's human exploration program can inspire our youth, advance our technological capabilities, and support our geopolitical objectives. However, it can only do those things if we are willing to keep our commitment to the dedicated men and women of NASA and elsewhere who are working hard to carry out the challenging tasks we ask them to undertake. As a National Academies panel has observed, and I quote, "There's a significant mismatch between the programs to which NASA is committed and the budgets that have been provided or anticipated. The approach to and pace of a number of NASA's programs, projects, and activities will not be sustainable if the NASA budget remains flat. As currently projected, this mismatch needs to be addressed if NASA is to efficiently and effectively develop enduring strategic directions of any sort," unquote. The long-term goal of humans to Mars, if properly pursued and supported, will inspire, will spur innovation, will promote international cooperation, and will advance science. In short, it is a goal well worth investing. With that, I again want to welcome our witnesses, and I yield back the balance of my time.
Thank you, Ms. Johnson, and I'll now introduce our witnesses. Our first witness is Dr. Scott Pace, Director of the Space Policy Institute, and a professor of the practice of international affairs at George Washington University's Elliott School of International Affairs. Prior to his work at George Washington University, Dr. Pace served as NASA's Associate Administrator for Program Analysis and Evaluation and as the Assistant Director for Space and Aeronautics in the White House Office of Science and Technology Policy. Dr. Pace holds a bachelor's in physics from Harvey Mudd College, master's degrees in aeronautics and astronautics and in technology and policy from MIT, and his PhD in policy analysis from the Rand Graduate School. Our second witness is General Lester Lyles. In 2003, General Lyles retired as the Commander, Air Force Material Command at Wright-Patterson Air Force Base in Ohio. Prior to his command at Wright-Patterson, General Lyles served as Vice Chief of Staff at U.S. Air Force Headquarters and commanded the Space and Missile Systems Center at Los Angeles Air Force Base. General Lyles received his bachelor's in mechanical engineering from Howard University and his master's in mechanical and nuclear engineering from New Mexico State University. Our third witness, Mr. Doug Cooke, is an aerospace consultant with over 40 years of experience in human spaceflight programs. Mr. Cooke retired from NASA after a 38-year career at Johnson Space Center and NASA headquarters, where he served as the Associate Administrator of the Exploration Systems Mission Directorate. Mr. Cooke led efforts to adopt the current vehicle designs for the Orion and Space Launch System. He also had senior leadership responsibilities during critical periods of the Space Shuttle, International Space Station, and human exploration, human spaceflight programs. Mr. Cooke is a graduate of Texas A&M University with a Bachelor of Science degree in Aerospace Engineering. Our final witness is Dr. Sandra Magnus, Executive Director of the American Institute of Aeronautics and Astronautics, the world's largest technical society dedicated to the aerospace profession. After being selected to the NASA Astronaut Corps in 1996, she flew on shuttle missions in 2002 and 2011 and spent 4.5 months on board the International Space Station. Dr. Magnus followed her work on the ISS and the Exploration Systems Mission Directorate at NASA headquarters and served as Deputy Chief of the Astronaut Office. Prior to her work at NASA, Dr. Magnus worked for McDonnell Douglas Aircraft Company as an engineer working on stealth aircraft. She holds a bachelor's in physics and a master's in electrical engineering from the Missouri University of Science and Technology. She earned her PhD from the School of Materials Science and Engineering at Georgia Tech. We welcome you all and appreciate your being here and appreciate your expertise. And Dr. Pace will begin with you.
Okay, thank you, Mr. Chairman and Ranking Member Johnson, for providing this opportunity to discuss the topic of a strategic framework for U.S. human spaceflight, and specifically the opportunity of a human flyby and return to the vicinity of Mars in 2021, which is only 7 years from now. A primary challenge to creating a practical and sustainable program of human space exploration is not the lack of ambitious goals, but the difficulties in organizing a practical sequence of projects and achieve larger strategic objectives. We also know the space agency budgets are under great fiscal and political pressures, and funds to build a large human-capable lunar lander, much less support human landings on Mars, are unlikely in the next decade. Fortunately, the debates of recent years and a literal alignment of the planets provides an opportunity to bring together several major programs, destinations, and policy objectives into a sustained effort of human space exploration. As you'll hear, a sequence of affordable human space exploration missions could begin with Orion and SLS flights to cislunar space, followed by a manned flyby of Mars taking advantage of the 2021 alignment and the SLS. The 2018 window, of course, for Mars is even more favorable, but the SLS and other necessary capabilities are unlikely to be ready in time. Following a Mars flyby and the demonstration of the ability to reach Mars with humans that is feasible, the U.S., international, and private partners could begin a series of human and robotic lunar missions in the 2020s, phasing in as the ISS reaches the end of its operational life. These missions would build operational experience and demonstrate the technologies necessary to eventually land humans on Mars. The international consensus in places such as the International Space Exploration Coordination Group has coalesced around cislunar operations as the next logical step beyond the ISS. There are many cooperative ventures that we could talk about, but the Mars flyby mission serves as an interesting bridge, potential bridge, between where we are with the ISS, where we would like to be with Mars, and where our international partners and commercial opportunities are with human spaceflight beyond low Earth orbit. This approach that we're describing, I believe, is consistent with the national space policy and congressional direction. In a constrained budget environment, it allows major program elements to be phased in affordably. Conducting a Mars flyby in 2021 with a schedule firmly dictated by orbital mechanics would drive near-term program planning and decisions on how to rationally trade costs, schedule, risk, and performance goals. We need a vision and a strategy to be a preeminent spacefaring nation. As many know, I've argued for taking a more geopolitical and international approach focused on the moon. NASA has rightly said it doesn't have the funds for a lander right now. The White House has wrongly said that it's uninterested in the moon and has failed to connect the dots, in my opinion, of an exploration strategy that serves broader national interests. A Mars 2021 human flyby would, as I said, provide a kind of a bridge, bringing together Mars and lunar communities, and in many ways may offer a faster and more efficient way of returning to the moon. Much more detailed programmatic planning is urgently needed with respect to a 2021 deadline for a human flyby. Cost estimates, risk assessments, architectural trades are needed to see whether programmatic phasing and peak funding requirements are indeed feasible and supportable. And if borne out, the Mars 2021 flyby should become a top priority for NASA's human space exploration activities after the safe operation of the International Space Station. I thank you for your attention, and I would be happy to answer any questions that you might have.
Thank you, Dr. Pace. General Lyles.
Mr. Chairman, Congresswoman Johnson, and the members of the committee, I thank you for the opportunity to speak to you today on the issues concerning the nation's human spaceflight program. I am a member of the National Academy of Engineers. I specifically chair the Aeronautics and Space Engineering Board of the National Research Council, which is part of the Academy. The National Research Council was created in 1967 to focus talents and energies of the engineering community on significant aerospace policies and programs. The ASCB works in concert with the NRC Space Studies Board. We work hand in hand. And over the past decade, we've looked at various studies associated with programs related to space exploration and all of the activities that NASA is involved in. I also was a member of the 2004 President Bush Commission, Space Commission, that looked at the implementation of the United States, new United States at the time, space exploration policy. I was part of that activity led by Pete Aldrich, the former Secretary of the Air Force, and we came up with some very strong recommendations that we think underpin the current space exploration program that NASA is currently embarked upon. I also had the honor in 2009 to be part of the Augustine Committee. Norm Augustine, the former CEO of Lockheed Martin, as you well know, was asked by the administration and by the Congress to look at the civil space program and human space program for the United States. We were chartered specifically not to come up with recommendations, but to look at options on how we might conduct space exploration for the United States. And then finally, I had the honor in 2009 of chairing an independent National Academy study titled America's Future in Space, Aligning the Civil Space Program with National Needs. The formal task of that committee, that commission rather, was to look at the rationale and goals for our civil space program for the United States. And we specifically came up with recommendations to align our space program to the national needs of the United States. Hopefully during question and answer I'll get a chance to elaborate on each one of those previous studies. I'll go back and mention that the Aeronautics and Space Engineering Board has not specifically addressed all of the questions that you're interested in this particular hearing. However, we've done a lot of things, I think, that touch upon the key elements and key concerns and opportunities associated with going to Mars, associated with space exploration, and certainly associated with the Mars flyby opportunity. In 2012, specifically, the Aeronautics and Space Engineering Board, the National Research Committee, and the National Academy itself completed reviewing a series of NASA space technology roadmaps. We provided NASA with what we consider to be a very comprehensive list of technologies that need to be addressed if there was going to be any chance of getting to Mars, even in the year 2030, 2020 timeframe. We provided that to NASA. They embraced it, as I understand, and our recommendations for a technology roadmap are the underpinnings for the current technology programs. that NASA is embarked upon. Those technology roadmaps indicated that there are several high-priority technologies that require further development in categories such as radiation mitigation for human spaceflight, environmental control, life support systems, space propulsion, etc. It was a very, very comprehensive activity conducted over a 1.5-year time frame, and again, it underpins most of the technology programs that NASA is currently embarked upon. Relative to the Mars flyby task, and that we're specifically looking at here, in my personal opinion, the Inspiration Mars proposal provides, I think, an exciting opportunity for our space exploration program and certainly for NASA. It certainly is one that would provide vision. It addresses many of the concerns that each one of the studies I participated in was concerned with, including technology and technology maturation. But in my opinion, and based on my experience, 35.5 years in the Air Force, mostly developing space systems or high technology systems, it does have high risk associated with it. Scott Pace just described some of the things that need to be addressed, looking at costs, looking at risk, looking at technologies. But to me, it's something that needs to be addressed, and I think it fits in some respects with both the current space policy and certainly with the things that were addressed in the studies that I touched upon. Mr. Chairman, I will stop my remarks there. I've provided some specific written comments, and I look forward to your questions and the opportunity to talk about some of the previous studies in more detail in the Q&A. Thank you.
Thank you, General Lyles. Mr. Cooke.
Thank you, Chairman Smith, Ranking Member Johnson, and members of the committee for this unique opportunity to discuss with you the exceptionally important need for a space exploration roadmap, and specifically how a human Mars flyby mission in 2021 contributes to long-term exploration goals. It is long past due for the United States of America to have a cogent, meaningful plan for human space exploration. At a time when there is so much potential to make significant progress, I am more concerned than ever about the future of human space exploration due to the current void in long-term direction. We are, in my opinion, in dire need of a strategic plan consisting of logical goals supported by tactically placed specific missions that lead to a landing of astronauts on Mars. Logically sequenced missions should address science, exploration, and other objectives. International collaboration is essential, but the United States must lead. Capabilities and technologies should be developed incrementally and paced with available budgets. Every mission undertaken and every capability developed should contribute to long-term exploration objectives. Investments in current NASA human spaceflight programs are important, providing a balanced and solid foundation for human space exploration, including the International Space Station, crew and cargo transportation to low Earth orbit, and the Space Launch System, Heavy Lift Rocket, and Orion capsule. These are the critical building blocks of an exploration infrastructure. Additional enabling capabilities, technologies, and research, including advanced in-space propulsion, space radiation research and protection, cryogenic fuel storage, closed-loop life support systems, spacesuits, entry, descent, and landing technology, and others should be the focus of NASA technology programs. First, we need a long-term roadmap that can gain traction through debate and refinement by stakeholders and advocates of the various approaches. Beginning with a human Mars Venus flyby mission in 2021, a unique mission opportunity with a free return trajectory made possible by the exact Earth-Venus-Mars planetary alignment. It is the least complex mission profile for reaching the Mars vicinity. The next comparable flyby opportunity is not until 2033. The mission provides an opportunity for an incredible first step that will make travel to Mars real to the people of the world, demonstrating previously unimaginable possibilities in the span of a few short years. The essential capabilities for such a mission are an SLS vehicle with a fully capable upper stage, a habitat with an advanced life support system, and an Orion capsule with an advanced heat shield. A human mission to a large asteroid in its own orbit would be achievable with these same capabilities. The most logical next step for the 2020s are missions to our own moon. Spacefaring nations, including China and Russia, are all very interested in the moon. Astronauts would collect samples in high-priority locations already identified by scientists to learn about the history of the Sun, Earth, and solar system. They will employ surface operational techniques and test systems in the hostile lunar environment that will prepare for future human Mars surface operations. After initial lunar missions, Mars, moons, Phobos, and Deimos become logical destinations. Missions will require efficient propulsion, possibly through evolution of solar electric propulsion technology used today, nuclear electric propulsion, electric plasma engines, or nuclear thermal propulsion. Astronauts will be in close proximity to Mars for a period of weeks, harvesting science samples and operating robots on the surface with minimal communication delays. A mission to Phobos and Deimos would inspire and prepare us for ultimate landing of crews on Martian surface. A human landing to Mars will require a large lander capable of atmospheric entry, surface habitat, nuclear surface power, a lightweight spacesuit, a rover, and other assets. Human missions to Mars will be challenging and tremendously momentous as astronauts explore the planet most like our own. Through logical progression and meaningful missions, I believe Americans will be motivated to support appropriate but reasonable budgets that are commensurate with the value of the plan and the work needed to accomplish it. We cannot afford to delay or prolong the debate because timing is critical to catch unique planetary alignment that makes the first step possible in 2021. NASA should seriously consider these concepts and challenges and objectively examine how they can be accomplished. With a long-term plan, we can provide our youth and the rest of the world a future marked by technological progress and discovery that will inspire all to higher aspirations. In the process, we will regain U.S. leadership in space exploration with a cadence of achievements. I thank you for inviting me. I also want to thank this committee and your staff for continued leadership in human spaceflight. I'm happy to answer questions. I do have a short video clip if you have time. It's 40 seconds.
Why don't we proceed and have the video clip then? Is that all right with the ranking member? Okay, yes.
This video clip will show the mission trajectory starting from Earth, and then show what it might look like to go past Venus and Mars. So you'll see a trajectory path, hopefully, that gets to the Venus vicinity by April of 2022. This is what the crew would look and see of Venus as it flies by, not this fast, but and then a Mars flyby in October 2022. They would have about 40 hours of looking at Mars when it's at least as big as the Moon is from the Earth. And then it would be an Earth return in June of 2023. Thank you, sir. Thank you.
That is great. That's the first time I've seen it, sort of the practical application of the proposal. Thank you, Mr. Cooke. Dr. Magnus.
Chairman Smith, Ranking Member Johnson, and distinguished members, I want to thank you for the opportunity to address you today concerning the future of human spaceflight. I was asked to address the importance of having an exploration architecture and strategic framework to guide NASA's investments in space. In order to understand how important this is, I think we need to examine the trajectory of human spaceflight program over the previous decades. As we all are very well aware, President Kennedy's famous speech to Congress on May 25, 1961, challenged the country to land a man on the moon and return him safely to Earth within the next decade. Even though Kennedy's proposal was a noble goal, it was just that, a goal. Underlying that goal was neither a long-term strategy nor vision, let alone political consensus for how or what the U.S. should do in space. And because of this, the U.S. space program has since suffered. In the absence of a long-term strategic vision, we instead planned and executed short-term tactical goals outside of a larger defined stable framework, and this is the operational mode we are still working under today. So what has been at the heart of the problem of identifying and committing to a consistent national long-term strategic plan for the United States space program? Unfortunately, I believe that part of the problem is buried in human nature and our difficulty as humans in focusing in general in the long term, and coupled with our inherent short-term attention spans as the federal government that turns over at least a fraction of its governing structure every 2, 4, or 6 years, and the barriers to a long-term consistent strategy become painfully apparent. It is important to acknowledge these issues and overcome them together as we determine the course for our country in space for the next few decades. We live in interesting times. We find ourselves at a pivotal point where private enterprise, leveraging off of the foundational and groundbreaking work that the government has been conducting for the last 5 decades, feels that it understands the risk-reward equation well enough to start engaging in activities in low Earth orbit. But government has a role that it must continue to play in space exploration and utilization. The role of the government is to do the hard things, invest in the research and development the industry cannot, and to take on the tasks and push the boundaries that the private sector will not. Our strategy should consider how do we want the U.S. to be leveraged for future roles in space, both in commercial and civil, in low Earth orbit and beyond. It should not be an or, it should be an and. Our plan, our vision needs to be long-term and stable in nature and comprehensive in scope, well thought out and well articulated, and most importantly, fully resourced and executable. And finally, we need to maintain our long-term focused and steadfast commitment to our strategy on the order of a decade or so at a minimum. So the question being addressed today is, can the Mars Flyby mission be a candidate for deep space mission for the SLS system? I would say it is certainly one of many possible missions that could result. But once again, let me caution you, let us not return to the misguided lessons of the past. Any mission chosen cannot be done merely with the mindset of accomplishing a goal without clearly being tied to an overarching strategy. A mission such as the Mars Flyby or an asteroid retrieval or a lunar base should be put in the context of the required longer-term strategy. In the context of a coherent strategy, the appropriate missions will be defined logically based on the requirements developed within that strategic framework. The Mars Flyby thus can only be discussed in the context of a larger strategy and the associated missions and operational goals. I would like to underscore that any plan, whether its goals are to retrieve an asteroid, establish a lunar base, or send people to Mars, is doomed to failure without the resources to support it. Resources provided in a sustained and a sustainable manner based on realistic projections. NASA has found itself often in a position where it's given tasks to perform but then provided inadequate resources to fulfill them. Failure to adequately resource such large-scale endeavors from the outset inevitably leads to higher costs and inefficiencies. We must have a long-term commitment. Currently, NASA gets about 0.5% of the U.S. budget. If we're going to be a nation that has a future in space, a nation with a strong strategic plan and the will to execute it, 0.5% of the national budget is simply not adequate. The nation has some major budgetary issues to address. I will not deny that. But the heart of our budget problems does not lie in the increasingly small fraction of the budget available to discretionary programs like NASA. I believe a strong, stable, strategically directed, and appropriately resourced space program is vitally important to our country. A sustained national commitment to such a program will not only benefit our country economically, but also will serve as a strong motivation for our young generations to pursue challenging and exciting careers in science, math, and engineering, an intangible benefit, but an important one. Again, thank you for the opportunity to address this committee, and thank you for your continued support of the United States Space Program. I look forward to discussing this issue with you further, and I'm happy to answer any questions that you may have.
Thank you, Dr. Magnus. I'll recognize myself for questions, and let me address my first one, Dr. Pace, to you. And that is, how does the possible Mars flyby benefit from the continuing development of SLS and Orion? Are they a good fit for each other?
Well, yes, I believe they are a good fit. I mean, one of the things that is the challenge for Mars flyby is, of course, on return. You're coming in at a very, very high speed. So some of the experience from the Orion program that developed for a lunar return high speed is also applicable to the high-speed returns you require from the moon. The size and volume of the SLS is also very helpful. Many payloads, long-term exploration architectures, Doug Cooke can speak to this even better than I can, you wind up being volume constrained. So the large volumes that an SLS can place up also are very helpful for lunar and Mars exploration efforts. And of course, the propulsion capabilities that the SLS provides are really going to be quite impressive. And I should note that one of the requirements in here is a high-performance upper stage, a dual-use upper stage, to provide the kind of the trans-Mars injection velocities that you're going to need. But if we are going to be a spacefaring nation, going to the moon, going to Mars, asteroids, and other destinations, then a workhorse heavy lift capability like this, I believe, is integrally necessary to the nation to have.
Okay. Thank you, Dr. Pace. Mr. Cooke, I wanted to ask you, how feasible is it for NASA to basically meet the 2021 deadline, which you might consider to be immovable? Are we going to be able to stay on track with SLS and Orion, and what would be required for us to meet that deadline?
Yes, sir. I believe that 2021 is possible if the focus is put on getting that mission on our books. I think the development of the SLS is well underway. It would take a commitment to develop the full upper stage in the time frame that we're talking about. We would need a small hab, perhaps using an existing structure, but with advanced life support, which actually the Inspiration Mars Foundation contributed money to develop in the last year. Orion would have to get there. But there are enough years ahead of us that I believe it's definitely possible. But obviously, you have to focus on it near term in order to accomplish it.
Okay. Thank you, Mr. Cooke. General Lyles, appreciated your encouraging comments and wanted to ask you and Dr. Magnus a question. But let me set it up first. Even though you're encouraging, we all recognize that there are challenges there to achieving this particular mission. There are risks, and the technological challenges would include, for example, trying to figure out a way that radiation would not be as dangerous, carrying sufficient fuel and food and water, and so on. Dr. Magnus, you mentioned JFK's announcement in 1961 about getting to the moon within a decade. He beat that by a couple of years. But the point is that when Apollo was announced, no one had any idea how to accomplish that mission. The technological challenges were almost thought to be insurmountable, and yet we achieved them. So I guess I don't feel like the challenges here are any greater than NASA faced in 1961, and yet did a magnificent job of achieving the goal that had been set by President Kennedy. General Lyles, do you think, even though we have these challenges, do you think that it's possible that we can make the technological breakthroughs, that we can accomplish what we need to in order to meet the 2021 deadline?
Mr. Chairman, I think my personal opinion is yes, we can. I would never underestimate what the American spirit can do, and American innovation and American interest in technology can do. My concern are tempered a little bit by experience in looking at previous programs, not just NASA programs, but Department of Defense high technology programs. You never know for sure exactly what you're going to encounter, those unknown unknowns, to quote one of our former secretaries of defense.
Right.
There was a comment that we made in the Aldrich Commission, the President Bush Space Commission, that I think is very, very applicable here. It was a go as you can pay sort of strategy. It was looking at a specific goal, whether it's going to a flyby Mars or whatever it might be, and making sure that every step that you're taking advances towards that goal, and being flexible enough to take advantage of technological achievements that we can't estimate right now, or even some technological challenges that we probably can't estimate right now. The focus, somewhat like Doug Cooke mentioned, is to make sure we have a long-term goal and to focus on getting there and not be deterred in terms of that as our mission. I think the American spirit is such that we can do that, but we have to have the focus.
Right. Thank you, General Lyles. Dr. Magnus, anything to add? I know you mentioned the strategic vision as well as the practical, but do you think we can do it?
Well, I would certainly echo General Lyles. We can do anything we put our minds to, and it seems like my whole adult life we've been 20 years from going to Mars, and it's really just comes down to a matter of national will and commitment. If we decide as a country that it's important for us to go to Mars, we will do that because we will be given the community the resources and things like that. But I would like to comment as we discuss what going to Mars means, we have to be aware of once we get to Mars, what are we going to do there? I mean, one of the problems with the lunar program, which is a great program, I'm not certainly implying anything negative came out of that, but we went to the moon, and then it was like, okay, we've been to the moon, now what? You know, and we've been there, done that, and we shouldn't go back again. So we need to have a big picture plan. What are we going to do? We're going to go to Mars, and we're going to do X. So we just don't go to Mars, and then we stop going to Mars because we've now been to Mars. So that's why when I was speaking about a long-term strategy, that's
the
what I'm talking
vision.
about. The bigger picture, what are our goals, what are our objectives, what are we going to do there, things like this.
Very good. Thank you, Dr. Magnus. The gentlewoman from Texas is recognized for her questions.
Thank you very much, Mr. Chairman. General Lyles, what criteria should Congress use to assess of the adequacy of an exploration roadmap such that it can garner sustained support and funding from successive Congresses and administrations, and how can Congress ensure that the roadmap is adaptable to evolving technologies, tied to scientific discoveries, and can be a source of inspiration to future generations?
Congresswoman, I think Congress is owed in some respect a better definition of what NASA's technology roadmap is today. I would mention again the technology roadmap that was provided by the National Research Council, the National Academy, to NASA in 2012. And I think if we look at that very closely, it gives you sort of a measure is NASA really focusing on the kind of technologies that the academic community has mentioned are the right things to do if you're going to advance space exploration? That gives you sort of a barometer, if you will, a measuring stick to see if they are doing the right kind of things, or even if the resources are adequate to do that. I would also commend, Congresswoman, the study that I led on rationale and goals for our civil space program. We specifically titled the report that we gave back, Aligning the Civil Space Program to National Needs. Whether those national needs, those greater national needs, are energy, climate, health, environment. I think there's an opportunity to ensure that our civil space program, even going to Mars as a flyby, has adjoints to it that relate to the other greater national needs that are of such importance to the citizens of the United States. And knowing and understanding what that linkage gives another barometer that the Congress can look at to see if these programs are indeed not just giving us an opportunity to go to Mars, are they also addressing things that are critically important to the United States.
Thank you very much. What is your assessment of the progress being made for the SLS and the Orion, Mr. Cooke?
I believe that great progress is being made. As I understand it from reports, SLS is ahead of schedule. They will have their critical design review this year. There are parts, Pathfinder parts for the tanks being made at Michoud, and as well as flight hardware. I think that there's a pathway forward this year to get to qualification motor firings for the boosters. They've had successful tests of the test motors, very successful, that were predicted and resulted in, they had results right on the money. The Orion vehicle is being worked down at the Cape right now, down at Kennedy Space Center, getting ready for a test flight and I believe it's planned in September at this point. Ground facilities are being modified and gotten ready at Kennedy Space Center as well. So the programs I believe, are making very good progress.
Thank you. Dr. Pace, would you like to comment on
Thank you. I guess I don't have anything to add to what Doug Cooke has said about the SLS program. I have the same impression that he has in terms of the progress being made in terms of people focused on hardware. As we sometimes said in NASA, head down, coloring hard. People are working away at it. What I would like to add is to echo a comment from Dr. Magnus on the need for a larger context for all of these things. I think that's absolutely true for asteroid retrieval missions. It's true for a lunar base. It's true for a Mars flyby mission. And I think that the larger context that we're often missing is some of our national security and our foreign policy interests in civil space cooperation. Civil space cooperation is not something done just for fun or even just only for inspiration, as important as that is. It's also a way of drawing other countries to us and having them work and cooperate and participate with us. We as a country are more dependent upon a peaceful, quiet, and stable space environment than any other nation in the world. There are many, many new players coming into the world who are active in space, and many of them don't have the kinds of experiences that we have. So how do we bring them into the community of spacefaring nations to act in responsible ways? Getting them involved in cooperation, getting them involved in caring about having a peaceful and stable space environment is something that I think is deeply in our national security and foreign policy interests. So to the extent that we can create cooperative opportunities on the Moon, Mars, asteroids, that provide opportunities for other countries to work with us, we will be protecting our own national security. And that is a long-term geopolitical interest this country will have. President Kennedy met a short-term geopolitical interest with his lunar decision. We have, I think, an opportunity to serve our long-term national security and geopolitical interests with a program of space exploration.
Thank you very much. My time's expired.
Thank you, Ms. Johnson. The gentleman from California, Mr. Rohrabacher, the Vice Chairman of the Committee, is recognized.
Thank you very much, Mr. Chairman. When I first heard about this concept of the flyby with Mars, a human flyby, it was presented to me by a man who I deeply admire, Dennis Tito, who is a man who has inspired many, many Americans with what his own courage and his own vision accomplished years ago, and over the years has been very, very creative in his approaches to space. But when it was first, and I boiled on it, it was a great idea, but his proposal to me was, and to us, was a project that was fully funded by the private sector. And now, all of a sudden, it's not funded by the private sector anymore. It's the same mission, but now it's going to come out of the public sector money. And while I thought it was a great idea if people were willing to take the risks and spend the money in the private sector, I think this is a foolhardy use of very limited government resources as compared to if private people want to put their money up. General Lyles, good to see you again, sir. Always great to see you. And you talked about 35 years in Air Force and how you understood high risk that is associated with various projects. There is a very high risk associated with this, is there not?
Congressman, yes, there is. Whether you're talking the technology itself or even from a policy perspective, and certainly the funding aspect of it.
Both the technology end of it, both the funding end of it, and both the actual accomplishing the mission is just, there's many, many risks, a lot more risks than other things that we might accomplish in space with the limited dollars that we have if we expended those dollars toward those other goals. Isn't that the case?
Congressman, I would not disagree with that, but I think that's one of the reasons why I think it's very important to look at how that particular idea, a Mars flyby, could be linked to other things that we're already doing. The program that we're currently embarked upon, whether you call it asteroid retrieval or whatever the right title is, there are aspects of the technology we're developing for the current program, obviously SLS, Orion, that could be applied to a mission such as a flyby. I'm not quoting a specific time,
right.
So I think it could be linked to other things.
Well, but that's just with a space launch system. It can do other things. General, when we're talking about the risk, what would you say? Would you, if you had to put your own money into this, let's say you had to bet your mortgage money, would you bet your mortgage money on the success of this mission?
Congressman, my money wouldn't get us very far, probably at all. But the answer is right now, in terms of a vision, innovative idea, I like it. In terms of understanding all the risks, I would be reluctant to put my own money into that until I better understood what all the challenges are.
Well, thank you very much for being very frank with us on that. And Dr. Pace, you just mentioned the cooperative efforts, how important that is, and for all of nations to participate. Are there any other nations involved with putting money into this project?
Nope.
Okay, that's it. Thank you. I appreciate that. There is no. That's correct. There are not. And
could I add one?
Yes.
There were initial conversations on the possibility of contribution of a habitat structure. I mean, obviously, all those kind of things have to play their course, but there have been some initial discussions internationally.
There are some discussions. All right. When we go from some discussions to actually commitments, so there's a lot of space between those two. Now, let us note that this is a mission that has to be accomplished in 7 years. I mean, we have to do this within that 7-year period. All of these factors have to be together, and then the technology has to work. And I think, isn't this mission the very first mission that a SLS is going to have? And it's got to happen within that 7-year period. Would you like to give us your estimate as to a guesstimate as what the chances of, I mean, you've followed space programs. How many have really met their deadline in the last few years? Yes.
I'm sorry, I wasn't aware you were addressing it. Well, I think, again, if we really wanted to do this and we committed to do it, we could do it, but that means it has to be fully resourced with the appropriate manpower and
Now,
money and
the
everything
essential
else.
word, the most important word you used, and you used when you testified, was the word can and could.
Yeah,
That's a lot different than will.
exactly.
And the fact is that, do you really see that right now that there's a commitment in this country so that we don't start down this trail, spending a lot of money, and then at the end of the trail, not have accomplished the mission because the will wasn't there?
Yeah, that's the big problem. We don't have a really strong commitment for a long-term vision for our space program.
So we don't have it now, but we should move forward on this, even though we don't have that will now.
If you recall in my testimony, I commented that any mission that we do, whether it's a lunar mission or an asteroid mission or the Mars flyby, all needs to be in a larger context of what are we trying to do long-term as a country in space, and we need to make that plan.
The gentleman's
stick to that
time
plan.
has long since
The
expired.
gentleman, just 10 seconds, and that is just to say there are many great space projects that we need to fund. There are many of them, and this
Thank you,
not
Mr.
funding this
Rohrwacher.
would mean not that we're retreating from space.
And the gentleman from California, Dr. Baer, is recognized.
Thank you, Mr. Chairman, and thank you, Ranking Member, for calling this important hearing today. I think we've done our job as Congress and as this committee and subcommittee really codifying this commitment to future deep space exploration, and we want to see that happening. I think in the opening remarks by the Chairman and Ranking Member, as well as the opening remarks for all the witnesses, there's a consistent theme here. We need a vision and a strategy. Dr. Magnus, you talk about having this broader strategic vision. Where do we want to go, and then setting concrete goals. And I couldn't agree with you more. I mean, I grew up in a time, and many of us grew up in a time when, we were curious. We set goals. We didn't know how we were going to get to that goal. You invoked President Kennedy setting out that goal. We grew up in a time where, we talked about what we could do as Americans. General Lyles, you talk about, if we want to do this, we can do it. We don't shy away from that challenge. In fact, we can meet that challenge if, in fact, that's what we want to do. So we've got to set that goal. We've had the opportunity to meet with Administrator Bolden, a few months ago, again expressing this commitment to for NASA to set a goal, for the administration, the President to set a goal. We're working, with this committee, we've drafted a letter to the President because we want to see that commitment. We want to see a clearly articulated strategy from the President that says, here's what we're going to do, here's the time frame we're going to do it in, and here's how we're going to get there. We need that as a time frame. Dr. Pace, you touched on this is just not about going to Mars. It is in our geopolitical and national security interest to also continue to reaffirm our commitment and our leadership in space, because it is increasingly a national security issue. It is increasingly a geopolitical issue. With that, I look forward to working with our committee and subcommittee as we push the President to clearly articulate a commitment to deep space exploration. With that, let me ask some of my questions. Dr. Magnus, I agree with you wholeheartedly that we have to have a strategy here, and then we have to have clearly defined goals. What would you articulate as, if the President were sitting right here, what that strategy should be?
Well, clearly there's been enough discussion around Mars that the consensus in the community is that's our ultimate place to go. I think we still need to flesh out what are we going to do when we get there, and what's going to be our sustaining effort on Mars. Are we going to set up a base and have people visit it occasionally? What kind of science are we going to do? What kind of technology do we need to develop there to move even further beyond? So I think we still need some discussion about that. But in that context, then, I think the questions you need to ask are, what technology needs to be developed, what capabilities are important for our country to develop versus how we might leverage international cooperation, because I think it will be an international effort. So we have to look strategically at the capabilities and the technology and the types of experience we want our country to lead in, and then build that into the plan. Then we have to look at where we are from an industrial viewpoint, how we want to leverage the architecture to continue the utilization of low Earth orbit, and then what series of missions do you use to build up these capabilities and demonstrate them to reduce the risk of going to Mars? And those are the questions that would frame that plan.
Fabulous. So in a matter of 30 seconds, you've laid out a strategy, a goal, and some steps to reach that long-term goal. Part of this also is all the additional benefits we get when we stretch our goals. I'm a physician by training. I can think of numerous medical benefits as we deal with how we're going to deal with the radiation risk, how we're going to deal with the sub-zero temperatures and so forth. I mean, there's tons of applications that are going to come off of this, tons of jobs that will be created off of this. So again, I wholeheartedly encourage the President, and again with this committee, and look forward to working to push the President to clearly articulate what that strategy is, that goal is, so then we can do our job in Congress, working towards hitting that goal. And again, I would say we're a country that doesn't shy away from challenges. If we set a goal and we clearly articulate that goal, I think to quote General Lyles, never underestimate what the American spirit can do. And I wouldn't, if we want to do this in 7 years, we'll do it in 7 years. But let's actually make that commitment. So thank you. I'll yield back, Mr. Chairman.
Thank you, Dr. Barra. The gentleman from Mississippi, Mr. Palazzo, is recognized.
Thank you, Mr. Chairman. It's often been said that space exploration is a go-as-we-can-afford-to-pay endeavor. No bucks, no Buck Rogers. Congress has consistently provided more funding for the Orion and Space Launch System than the Obama administration has requested over the past several years. Congress has placed a higher priority on human spaceflight than the Obama administration. The current schedule for NASA's first manned flight is 2021 on the Orion and SLS, but that is based on President Obama's budget plan, not the higher budget level that Congress has authorized and appropriated over the past several years. So my question for Dr. Pace is, in terms of affordability for a Mars 2021 flyby or other space exploration endeavors like a return to the moon, is about setting budget priorities. In your opinion, what priority has the Obama administration's budget proposals given to human spaceflight compared to other priorities for NASA?
Well, I think there's been a decline in the overall NASA budget, certainly over the last several years. It's been quite volatile. The top line has vibrated quite a bit, and exploration monies have declined. So monies have shifted over into other priorities, certainly climate change research, technology work, all of which are perfectly reasonable and important things to do. But human space exploration has seen a long-term decline. But even more critical than the money, I think, has been the lack of a sense of, well, what do you do next? For example, what comes after the space station? What are the next steps that we're going to engage with other countries in? I'll say in general, a very positive view of the President's national space policy, which by and large I think is a very well-written and thoughtful document. The section of it that I disagree with is one on exploration, because I don't think it sets out a clear set of milestones and doesn't set out a clear set of priorities. So it's understandable that the monies that NASA does get often get diverted into other things other than human space exploration, because the national policy itself doesn't really clearly articulate what those priorities ought to be.
Mr. Cooke, in your assessment, approximately how much more money will be needed beyond the President's budget plan to accelerate the first crewed flight on the Orion, and how much more money would be needed to meet the 2021 flight to Mars?
I would say at this point there's more work that needs to be done on the 2021 mission. A fair amount of work did go into studying the technical aspects of the 2018 mission by the Inspiration Mars Foundation. I think that questions should be asked of NASA to go look at this mission seriously and get to an understanding of what it takes, along with taking advantage of the work that has been done on the 2018 mission. But to my knowledge, there's not been a detailed cost analysis of this. I would hesitate to state a number, but I would say that the directions that would be taken in terms of developing the large upper stage for SLS is what's needed long term. There are synergies that can be brought into that because of the work currently going on in the core stage of the vehicle, in tooling and actually in the design process. There are structures that could be used for the habitat. There's work that has gone on a more advanced life support, which is important for this flight. And the Orion vehicle was designed for missions beyond Earth orbit. So I believe there are steps that are not unreasonable, and could, with a commitment, as has been discussed, with a commitment, I think it's a reasonable approach. But the mission needs to be looked at in the terms, once again, of a long-term plan, so we know how it feeds forward. I mean, I believe it does.
Thank you. Dr. Magnus, as a former astronaut and deputy chief of the astronaut office, as well as an accomplished engineer and executive director of the world's largest technical society dedicated to the global aerospace profession, how would a Mars flyby mission be perceived by those individuals responsible for designing and flying such a mission? And understand that you not officially speak for them. Would astronauts be comfortable with the risk posed by such a mission?
Well, I can state quite frankly, any mission that you can come up with that sends people into space, you'll have plenty of volunteers to go. There's unquestionable. I mean, there are people signing up to go one way to Mars, regardless of the definition. That's the pull of spaceflight. That's the pull of space exploration on everybody. Now, as an experienced astronaut, the questions that I would ask at this moment where the mission definition is coming together is, what exactly does the life support system look like? How is it working? What kind of redundancies you're going to have? The radiation question is still a big question. Understanding, we're getting some data from Curiosity, of course, and its traverse, and even currently, I would want to understand a little bit more about how we were going to design to fix the radiation problem. And then after I came back, if I was going to be exposed to a lot of radiation and accept that as a risk, what were you going to do to take care of me long term if 10 years from now some weird thing happens to my body? I would ask those kind of questions. I would also ask, as someone who's going to be an operator on a mission like this, what am I going to do during the mission itself? There is a lot of work to do on the space station. We're extremely busy on the space station. We do have time to relax and sort of decompress a bit. And for you guys have very challenging work schedules here, and I think you understand that when you're busy, time is flying by. You're feeling like you're very useful and you're contributing to something. But if you are sending two people to Mars on a flyby, they're going to need something to occupy their time. They're going to need. So I would want to know, what am I going to be doing during the mission as well. I would want to understand the systems and the mission parameters. You're asking me to take this risk, and what are we going to get out of it? What's the goal? What context is it in? What comes next? How does this work into the bigger plan? So these are the kind of questions that I would be asking.
Thank you. I yield back.
Thank you, Mr. Palazzo. The gentlewoman from Maryland, Ms. Edwards, is recognized for her questions.
Thank you, Mr. Chairman, and to the ranking member and to the witnesses today for your testimony. I have to say it's been interesting to listen to the concerns that have been expressed about the budget because, of course, there were people who were perfectly prepared to see NASA operate under sequestration levels, which certainly would never get us to an overarching vision to make our way to Mars and back. And so I'm glad that we're tried to change this conversation a little bit and look realistically at what it is that that the space community needs to do, the scientific and research community, but also NASA. I've been really, and I am, Dr. Magnus, one of those people who would probably certainly volunteer to leave this committee in the Congress and go to Mars and not return. But nonetheless, I do think that there are some questions that we need to answer, and I think, Dr. Magnus, you've laid those out quite well. I'm curious as to what you all think the Congress needs to do in terms of directing NASA in terms of a timeline to provide a roadmap that would be reasonable then if we were to proceed along this goal to 2021 and then into the 2030s. So do we need to be more directive in terms of asking for something back from NASA by a date certain? And do we need to say to the agency, you and who else around the table should come up with the roadmap and the plan? My fear is that it might be left to members of Congress who have no real scientific expertise at all to be able to determine whether it's the moon, a Lagrangian point, the International Space Station, or an asteroid that makes most sense for precursor missions to get us on our way to Mars. And so I would hate to leave it to us to do that, and I'd like you to help me think through who needs to be around the table and by when do we need something so that we can begin the kind of planning that we need for budgets and program. And so any of you, if you have some comments about that.
Congresswoman, let me just take a quick stab at that, if you will, from perhaps a little different perspective than some of the other witnesses might espouse. I would hope that the Congress would look at NASA as an agency from an enterprise perspective. And by that I mean, when I go back and look at President Bush's original space exploration program that was laid out and the commission that I served on as part of that, we looked at the broader sense of space exploration. Even the space policy, the new space policy that Scott talked about, looks at space in the holistic sense. Human space flight is just one element of that. And I would hope that the Congress, when considering budget needs and budget concerns for the agency, will look at the broader context of space exploration, and even, if I add for the first A in NASA, the aeronautics needs for this nation, and look at it from a broad sense of understanding how all of those contribute to the needs for the United States, whether it's addressing other national needs, as I mentioned earlier, or whether it's addressing the broad needs of space exploration, but look at it all in a holistic manner, not just human space and going around Mars.
Thanks, General Lyles. Dr. Pace?
Thank you. I would actually say that the 2010 NASA authorization bill, certainly at the policy level in terms of framing what the Congress's priorities are, is really quite good. I mean, I would personally like to see some of that language maybe incorporated into the national policy. So in terms of philosophy and priority, I think that's already there. I think we know some of the constraints that bound the analysis that NASA would have to do. Continuing the space station through 2024, the capabilities of SLS and Orion being available. We know the international community longer term is interested in Mars, but we also know the international community in the nearer term has coalesced around cislunar space, the global exploration strategy, the technical discussions that the International Space Exploration Coordination Groups have done. They all see cislunar space as an area that's challenging but reachable for them to do. So those major pieces, space station, Mars, the cislunar space operations, where the international community is, those major pieces are actually all largely in place. So the analysis that needs to be done is more at the cost, schedule, and risk standpoint, which I think is within what NASA can do. And if you
So when should we expect something like that back so that we can begin to act on it?
I think if you tasked NASA to generate some architectural trades like that, and they put some series of efforts into it, I think on the order of a few months would be perfectly reasonable. Tons of these architectural works have already been done. Doug Cooke has done and read most all of them. I'd be hard-pressed to think of one he hasn't read. And so the material and information is there. I think it's really the cost and the budget analysis and the programmatic phasing of what's sustainable is really the biggest uncertainty.
So is it a matter of simply giving NASA a directive and a time frame so that we can then get on the process?
With some clear constraints, and that if certain requirements can't be met, or certain budget caps and whatever can't be met, then a prioritization of what you relax. So a sense of priorities in order for programmatic management trades to take place.
Thank you.
Okay.
Thank you, Mr. Chairman.
Thank you, Ms. Edwards. The gentleman from Illinois, Mr. Hultgren, is recognized.
Thank you, Chairman. Thank you all for being here. Appreciate so much your work and this important topic of really creating vision for our future. I especially want to thank my fellow Illinoisan, Dr. Magnus, for her amazing work and amazing story. I just love reading your biography and all that you've done. So I appreciate you being here and appreciate your great work. I want to address my first question to Mr. Cooke. In your written testimony, you say that a long-term plan should be adaptable based on discoveries and budget realities. I wonder, to provide consistency to long-term goals, the committee has passed NASA Authorization Act. It calls for the exploration roadmap to be updated every 4 years. I wonder, should the plan change more often than that, or do you think that risks and leads to instability?
Well, I think it depends on what level of change you're talking about, of course. And I think it's valuable to ask for an update on a regular basis. I believe that if discoveries are made that are really profound, that we will all be talking about it when it happens, and those are the kind of things I'm talking about. The Mars Science Program is an example where they've had roadmaps for years, and they adapt almost after every mission because they make discoveries and it points to new directions. It doesn't mean that you want to throw away everything that you're doing in terms of an infrastructure. You want to understand this long-term plan such that it is adaptable. You want to have the heavy lift rocket on the front end. That's critical first step. The capsule you need no matter what. But I think a long-term plan helps guide you in what your infrastructure is. So and you can, as you go along, foresee some changes. But I think it all can be done if you keep in mind that the flexibility should be there.
So just to clarify, for our responsibility, would you endorse flexibility to be written into its design that allows for updates on an as-needed basis? And wonder if you could just talk quickly about how could a Mars flyby fit into that type of roadmap?
Yes, and so I do believe that there should be flexibility, as I said. And in my written testimony, I went into a lot more detail than I was able to do in 5 minutes on all of this. And in fact, back in May, I testified and put together how you might go about putting together a long-term plan. I believe that the Mars flyby mission does fit. I mean, I can view a series of steps. I outlined very quickly here, but I can view a series of steps that builds capabilities as you go, and each step contributes to the next step and builds on what has already been done. The Mars flyby mission, in my view, it brings the Space Launch System capability up to a level of performance that will be needed longer term than the initial test flight capability. I believe that the life support system in a small HAB is usable. If there are to be asteroid missions, you can use it. You would want it in going to an asteroid. It would be of value in cislunar space. That is a capability that has long-range benefits. Bringing the Orion capsule to its full capabilities is beneficial for a series of missions and a roadmap.
Let me jump on that, if that's okay, and open this up to everybody else as well, whoever might have a response in my last minute or so here. Dr. Paul Spudis' written testimony from last year's hearing notes the shift to the flexible path for human exploration that focused on the development of technology rather than a destination. What would you say were the most important exploration technology achievements of the past 3 years, and how do you think these achievements would have differed if our space program were guided by a specific destination? Any of you have any thoughts?
I think, first of all, I don't think there's any disagreement that NASA needs to develop new technology. There is a ton of new technology needs that should be made available to us, and NASA is working on a lot of them. The problem is how do they prioritize those technologies, because you can't do everything at once. So then the question is how do you prioritize? What's the policy objective? When people talk about destinations, they often do it in terms of a physical destination, Moon, Mars, asteroid, as if it's, either or. And I think what you're hearing from this group is, well, we sort of want all of the above. But the destination we're trying to get to is not just a physical destination in space. It's actually a capability for the country, the ability to operate anywhere we want in cislunar space, the ability to lead other countries in exploration missions beyond Earth orbit. And so in order to prioritize those technologies, we need to set costs and schedules and risk and trade-offs and decide what's more important than something else. That's where the longer-term context and plan comes in. And I think that if we have a larger policy objective of where we want the United States to be, the physical destinations fit into a sequence. You can then say, and these are when we need to hit various technology milestones. One of the great flaws of the current capability-driven approach and flexible path and all that sort of thing is that people then argue for whatever their favorite technology is, and it's not against an external metric, an external customer that you're trying to meet. It's people just working on really neat and important things. And in a fiscally constrained environment, that isn't really terribly helpful. So having a policy context and then a series of destinations as policy destinations is probably the most efficient way to spend taxpayer dollars and prioritize those technology investments.
I appreciate that. Again, thank you all so much. Thank you, Mr. Chairman. I yield back.
Okay. Thank you, Mr. Holgren. The gentleman from Texas, Mr. Weber, is recognized.
Thank you, Mr. Chairman. General Lyles, you mentioned in your comments earlier that NASA, that Congress was due or owed a technology roadmap from NASA. And then you also said, in your opinion, there was 4 national needs: energy, climate, health, and environment. Where did you get that outline?
Congressman, my first comment about the technology roadmap sort of stemmed from the research and study done by the National Academies a couple years ago and provided to NASA. It laid out technologies that we thought were critical towards achieving the objective and the goals, somewhat articulated by Dr. Pace and Dr. Magnus, of space exploration and making sure we understand the kind of things that we need to address if this nation is going to advance towards that broader goal of achieving and maintaining superiority in space exploration. I think since we provided it, we, the Academy, have provided that to NASA, and it really is the underpinning for the technology things that NASA is doing today. I think the Congress needs to better understand what it is they're doing and what was provided to them from the National Academy of Engineers.
Okay, well, the reason I'm asking is it seems to me that there's a 5th item that's probably missing. You don't, and I don't know if y'all considered it or discussed it, but you didn't mention national security, and I would argue that some of the things we gain by having an understanding of space and space superiority is, as you know, in military, the whoever occupies the high ground has the upper hand, and there is no higher ground than space.
Congressman, I agree with that 1,000%. In our report that I was quoting from about those other national needs, national security is the first one. I didn't mention it in my notes, but it is the first one. And as an example, other things like health, environment, climate, et cetera. Believe me, I resonate with the need to ensure that whatever we're doing in space underpins and supports our national security needs for the United States.
Okay, well, I just wanted to ask that because I wrote those down when you said that, and I thought it was conspicuous by its absence. And I agree with you that Congress needs to understand NASA's. There's a whole lot of things Congress needs to understand, better understanding of. And then you also said that Congress needs to look at NASA from an enterprise perspective. And you said the aeronautic needs for the nation and the space exploration needs for the nation. But again, you didn't say anything about national security. So I want to make sure in this context that we make that clear that it's important for our national security.
Congressman, I agree with you 1,000%. As I mentioned earlier, most of my career in the Air Force dealt with developing space programs, and believe me, they were all focused on national security needs.
Okay. And then, Dr. Pace, you said earlier that what's needed is an analysis of a cost schedule and a risk analysis. Define risk.
Well, there's a number of different aspects of risk. I mean, the first and probably the most important one is what do we know about the risk to human life? That is, can we provide informed consent for the people who are going to be volunteering to go out there? We have some missions upcoming, 1-year-long expeditions aboard the space station that I think will give us some more information about long-term human spaceflight that will be helpful. So human life, I think, is number one. The next one are sort of really cost and schedule risk. That is, what is the probabilities of hitting certain cost and schedule targets? Cost estimates are always probabilities, are never just point estimates or certain confidences that you have. And you can trade cost and schedule and risk with each other. That is, if you want to put more money into something, you can buy schedule. If you don't have that money, you need to stretch schedule, you can do that. So those kind of trade-offs. What's interesting about the 2021 flyby is the orbital mechanics pretty much set that schedule. And so within an affordable profile, can we hit that schedule with some confidence? Now, the time between 1961 and 1968, when we flew Apollo 8 around the moon, was 7 years. But that was in a very different budget environment. On the other hand, we know a lot more today than we did back then.
And
that's the trade.
That's getting to the heart of my question, too. When you talk about budget analysis and risk analysis, of course, Congress working on 2-year terms for a session, has there been discussion or thought about what is the optimal, budget? In other words, we'd love for NASA to have a clear, concise goal and without the politics of having the budget go up and down all the time, which I understand we're constrained by the money that we have as well. Is it feasible to say that we ought to be able to set a policy area of 4 years, 6 years? I mean, certainly we don't want, the longer the better. What do you foresee? Can we set a plan in motion and maintain it for 4 to 6 years, budgetarily speaking? Or is that just, pardon the pun, pie in the sky?
Well, I think it is actually perfectly possible to set relatively stable long-term budget plans if they are tied to long-term national interests. We've been able to support science programs over fairly long term. We support military space programs over fairly long term. So it's really only in the area, I think, of human spaceflight where we've seen a large and I think excessive amount of volatility because it hasn't been tied to enduring national interests, whether national security, international diplomatic outreach, scientific ties, or even promotion of private sector sets of interests, economic interests. I think there are these interests out there. I think we can make it a more explicit linkage, and if we did that, we would find it easier, not easy, but easier, to sustain stable budgets as we have in many other areas of space.
Okay, and I'm past my time. Thank you, Mr. Chairman.
Thank you, Mr. Weber. The gentleman from Florida, Mr. Posey, who represents Kennedy Space Center.
Thank you very much, Mr. Chairman. One of the fears that I have is that we even regress further. You all are familiar, I'm sure, as this committee is, with over 24 multi-billion-dollar programs to nowhere that were started by one administration and stopped by another, started by one Congress and stopped by another. And so, the first thing I think we all try and fight to do is do no harm, first of all, and stop us from aggressing. Someone mentioned earlier that our share of the budget for space now is about 0.5%, which is correct. The public perception on survey after survey is it's around 20% of the total budget. So, if we could get just half as much as the public thinks we're getting, we could really make some big strides in space. One other thing I think we need to note when we try and compare Apollo with missions of today is, they used a slide rule during Apollo. They didn't have the computer capabilities that we have now. The IBM computer mainframe is maybe a third as big as this room. And, you can buy a little credit card size calculator at Walmart for $5. It'll do more than that way back in the day. So we have advanced greatly in technological ways, and I think it's only a matter of money that will determine how far and how fast we can go in our manned space program. But what I'd like to ask from each of you, briefly, if you'd feel comfortable with it, is to share with us what you think the order of milestones, missions, targets should be in the next 5 to 10 years. Like, if you think we should go back to the moon, if you think we should go to Lagrange point, you think we should have colonization of the moon, and then another space station halfway to Mars, a Mars flyby in 21 or 31, landing and colonization. What order of targets would you establish if you were able to make those decisions? We'll start with Dr. Pace and go down.
Thank you, sir. I've been an advocate of returning to the moon, international human landing on the moon, with international partners and also with private sector partners. We have a whole separate discussion about cargo delivery to the lunar surface that can be done in a commercial-like manner. But the reason, and I think Mars is the longer-term objective with asteroids in between, the reason for that sequence is that the moon provides the greatest number of opportunities for public and private sector partnership with the United States. The reason why I think the Mars flyby deserves a look is because it demonstrates a lot of technologies that are useful across the board. It would put the U.S. in a position of leadership, and the timing of it would fit, I believe, within the budget profiles that we see going forward. We don't have enough money in the near term to support development of a major lunar lander. We're still developing SLS. We still have the ISS program. So I think from a programmatic and a technical development standpoint, the flyby fits if it's placed in a context of a larger mission. But I'm a fan of returning to the moon first and then moving outward.
Thank you. General?
Congressman, I'm sort of guided by the Augustine Committee report because I was one of the signatories on that and a member of that activity. We looked at options for our space exploration, human exploration program, whether it should be Mars first, Moon first, then Mars, or a flexible path. And all of us sort of decided that the flexible path we thought was the best option for the United States, given our technological presence today and what we need for the future. It gave us an opportunity to visit sites that we'd never visited before, to extend our knowledge of how to operate in space, and whether you consider Lagrange points, asteroids, or orbiting Mars, which was one of the options that we laid out in our report. We think that having a flexible strategy that allows you to be able, as you gain knowledge, gain technological knowledge and understanding, gives you the option to do any one of those, we think is really the right answer.
Yeah, well, I just hope we don't study our naval for the next 2 decades, that we set some targets and some goals and we attack it. Mr. Cooke.
I personally believe that we should have a path, and I was one who started the flexible path idea because we needed to start the SLS and Orion when I was still at NASA. However, once those are underway, because those are the 2 critical steps that you'd lead off with, once you have that, you do need a plan because it helps you make decisions on those designs even, in terms of where you go and what you do influences how you design things. And so I have always thought that the next logical step is the moon. Now, in this case, we're talking about a Mars flyby. I don't think that is contradictory. It does feed forward, and the capabilities feed forward to the next steps. This just happens to be a unique planet alignment that allows this mission in the near term. But certainly, lunar exploration is important.
Dr. Magnus?
So again, I would go to the first question is, what is the overall goal? If the overall goal is to go to Mars, and we're going to define what we're going to do on Mars, whether we're going to establish a outpost there to do specific kinds of science and types of exploration, then you back up from that. What's the logical set of progressive steps you need to take to get there, and what are the capabilities and the operational parameters you need to develop and demonstrate to build up that capability to go to Mars and do whatever it is you're going to do there. So we have got this great orbiting platform called the International Space Station. We can do a lot of technology demonstration and development there. There are probably things that we cannot do on the space station. We have the moon in our backyard 3 days away. If you're going to test out technology that you want to demonstrate to reduce the risk of going further away, you're going to test it in your backyard first. Whether you stay on the moon and establish a settlement there, it depends upon how that fits into your long-term goals. But I could argue if we established a beachhead on the moon to do technology demonstration, why would we not encourage our private enterprise partners to come and establish work there as we continue to move that boundary out? I mean, think of it as an expanding bubble with the government leading the edge of that bubble with private enterprise and industry filling in behind us. That's what we're supposed to do as the government, is all of these hard things and break down these barriers. So go to the moon, you test what you need to do on the moon, but as the government, you keep pushing that boundary. Our plans, you keep pushing that boundary. Do you go to cislunar space? Perhaps, if there's capabilities you need to develop there. Do you do a flyby of Mars? Perhaps, if that demonstrates the buildup of that risk reduction and the technology demonstration you need to do in order to put people on the surface. So it builds out very logically, and it's in a higher strategy of how you bring everybody along with you, internationally and in the private enterprise. That's how I would approach it.
Thank you. All good answers. Thank you, Mr. Chairman.
Thank you, Mr. Posey. The gentleman from Texas, Mr. Stockman, is recognized.
Thank you, Mr. Chairman. I have two questions. I know I don't have a lot of time, so I'm going to put them together, and they're disjointed in somewhat. I was interested in the solar electric propulsion, and I think, Mr. Cooke, you could probably address this, and in terms of how it could change the dynamics of space. And the other question I have is the abdication of the United States, in apparent abdication, to allow the Chinese to go forward with this space program. If we continue on the path where we're not in the forefront of space, how could that lack of leadership set the dynamics for our country and our economy?
I can address actually both questions from my own view. I believe that solar electric propulsion is one of the technologies that could have a big impact. When we go to Mars, the masses are pretty big for sending a crew there. In studies that we've done in the past, solar electric propulsion, plasma engines, nuclear thermal, nuclear electric are propulsion techniques and capabilities, technologies that reduce the amount of fuel that you have to put in low Earth orbit in order to go. It actually can reduce the human mission to the Mars surface and back by a factor of 2. In terms of one half of the mass it would take with current chemical engine technologies would be needed if you used one of these advanced technology approaches. So electric propulsion or one of those is actually an enabling capability for a Mars mission. Now, I believe that personally believe that our nation needs to remain a leader in space, in human space flight. I believe that in history, the nations that have retreated from leadership and exploration have retreated in the world front. And you can name countries like Spain and Portugal. Great Britain ruled the seas at one point, no longer does. They were explorers. The exploration goes with a national drive and incentive and motivation that is sometimes may be looked at a little disconnected from exact needs on Earth or in society, but it is something that great nations do. So I think if we retreat from these kind of aspirations, we will retreat in the world.
General Lyles.
I certainly agree with, I think, everything that Doug just articulated, particularly about the specific solar electric propulsion. That has been one of the key areas that the Department of Defense has worked on in its space technology programs because of the obvious benefits to not just human space flight, which is not our regime in DoD, but even to unmanned activities and station keeping, a bunch of other things that we need for national security space. So I agree with that. On the second comment, I'm 100% believer in making sure that we, the United States, maintain our leadership in space, maintain our leadership in aviation and aeronautics, which is why I mentioned the other A in NASA in my earlier comment. To me, if we don't, we literally run the jeopardy of becoming a second-rate power, which is something we do not want at all.
Yeah, I'm going to add my own 2 cents in there. There's some projections that China is going to exceed us in the next 15 years militarily, where NASA and the military seem to be separated. There's a wall there, somewhat of a wall. There is some cross over. But the PLA and their space program is very closely tied. As you know, they shot down a satellite. And I'm alarmed at the rate at which the Chinese are accelerating their expenditures and their technology. And I agree, historically, throughout world history, the people that abdicate the science of adventure abdicate the responsible as a world leader. And I really dread the day that we see that China supplants the United States, which is not a democrat country.
Congressman, let me just add, I agree with you 1,000% there. I think as the other witness can attest, and certainly some of the members of the committee, there's probably greater cooperation between the military and NASA civil space and national security space than people know. But I'm a big advocate of that there needs to be more, and particularly in the area of technology and technology development in space. I constantly remind people that the missions may be different, but the physics are the same. And there's a lot more that could be done between the two agencies to, in some respects, leverage their combined budget.
I could add one comment. There is a strong connection in terms of our aerospace industrial base. Both military and NASA use the industrial base that supports both, and it's somewhat underutilized at times, and they're downsizing. It's in all of this. It's important to have that capability as a country. It's one of our strengths.
Thank you, Mr. Chair.
Thank you, Mr. Stallman. Does the gentleman from Texas, Mr. Weber, want to be recognized again? The gentleman is recognized for a minute.
Thank you. I'm fascinated by the electric solar propulsion. Are there private industries doing that? You said 50% of the fuel would be less if you went solar propulsion, Mr. Cooke. Are there private industries doing this as well?
Industry is definitely involved in development of this technology, and the technology in electric propulsion is being flown. It has flown on science missions. Deep Space One, Dawn, or science missions that it is flown on. It is being evolved to higher levels of power.
Would you consider this a game-changing technology?
I would consider it a game-changing technology when it may make the difference between human missions to Mars and not going to Mars.
Okay, and should this be a priority for NASA?
It should be one of the key technologies that is pursued. I agree.
Okay. Thank you, Mr. Chairman.
Thank you, Mr. Weber. I'm sorry. Oh, I'm sorry, Dr. Pace. Do you want to be recognized?
Please, sir.
Yes.
I just wanted to add on to Mr. Cooke's comments. When we had the government shutdown last year in October, there is a conference happening at my university on electric propulsion. And so with no government attendees there, we still had 400 people from around the world, all from industry, academia, because electric propulsion in general, the solar electric propulsion is a bit more advanced, but electric propulsion is something that the communications satellite industry is very, very interested in. It is something that will be changing the future of the market, will be affecting launch services. And so there's certainly a lot of excitement and private interest, certainly in academia and industry right now on that technology and applying it.
Okay. Thank you, Mr. Chairman.
Thank you, Dr. Pace. And the gentleman from Maryland wants to be recognized and is recognized.
Thank you, Mr. Chairman. And just really briefly, I just want to express to the panel that I think that this has been an excellent panel of witnesses. And I always like it when I can come to a hearing and actually learn some things, and I really did today. And so I really appreciate your testimony. I appreciate the chairman and the ranking member calling this hearing because I would like us to be more invested as a committee and a Congress in really to help do what Dr. Magnus described, which is set a vision, a strategy, something that all of us as Americans can really embrace about our space program. And I think that you all have done an excellent job today of helping to crystallize our thoughts around that. So thank you.
Thank you, Ms. Edwards. And we have no more members to ask questions, so that does conclude our hearing. But I, too, want to thank the witnesses for being here today. You have contributed significantly to our understanding of the pros and some of the risk involved with the Mars flyby, and everybody seems to consider it to be a viable option. That is encouraging. And, of course, we need to have that overall strategic plan, Dr. Magnus, as you mentioned as well. And we hope NASA can produce that. Dr. Pace, you mentioned we might be able to get that in just a matter of months, and of course that would be helpful as well. More than anything, we just need for NASA to come to pick missions that and fund missions that are going to contribute to our knowledge, that are going to inspire the nation, and we hope to get to that point. So thank you all again for being here. Much appreciated. We stand adjourned.